So at the end of last class, we were talking about the int types, so primitive types in Java, and we were talking about the types that you'd want to use when you need an integer value. And so the type that you want to use when you use an int value is called int. Now remember that with all the primitive types in Java, they all occupy a predefined and fixed amount of memory. So there's a minimum and maximum value for all of the primitive types in Java. So for int, your minimum and maximum values are stored in the constants integer dot min value and integer dot max value. Right? They look pretty big. Right? So they're let's see. So we got three, so that's millions. So about 2,147,000,000. Right? So the numbers are quite large for many purposes, right? But they're not large for all purposes. So if you want to write, if in your program you write down a number on its own, right? So just a digit with no decimal point and nothing else, right? So digit or digits with no decimal point or other letters after it, then you end up with what's called an int literal, right? So a literal is just any number. An int literal is any number that you can just write down, right? So -1, right? That's an int literal. Right? 99, 98, 1, and 0, they're all int literals. Right? Now, if you want to, you're allowed to put a big L or a lowercase l, not a 1, right? Lowercase l, after the number. And that also indicates, oh, wait, sorry, that's wrong. Do not put an uppercase L or a lowercase l after the number. That indicates something else. Right? So a number on it, a digit or digits on its own represents an int. Right? If you want to, you are allowed to use the underscore to separate digits in the number. Right? So that's fine. It's often convenient to do when you're writing down long numbers. Right? If you know about binary, octal, and hexadecimal, then Java has a way to write down those literals as well, but we're not concerned with those in this course. If you want to, you just look it up. It's pretty straightforward. Right? But you need to understand how binary, octal, and hexadecimal numbers are represented. So remember, there's a minimum and a maximum value for all primitive types. And so if you do arithmetic with int, right, the question becomes, well, what happens if I take two really big int values and add them together? What do I get? Right? So the Java standard says, if you perform any arithmetic operation involving two ints, you always get back an int. Right? So any operation involving two ints, you always get back an int. That includes division, right, which is different from Python. Right? So in Python, if you write 1 divided by 2, you get 0.5. In Java, you get 0. Right? So in Java, division is defined at int division is defined as throwing away the fractional part of the quotient. Right? So 1 divided by 2 is 0.5. Throw away the 0.5, you get 0. Right? And that's the way that int division is defined. It's also the way that int division is defined in languages like C and C++. So here we've got a bunch of int values, right? 1, 3, and 13. Right? The operators are the usual operators, right? So they're all the same as in Python, right? So the plus sign is addition, minus sign is subtraction, the asterisk is multiplication, / is division. Python has // which they may have told you about. Java does not. Right? So Java only has the one / division operator. You can use parentheses, of course, to define the order of operations, right? Or to make explicit the order of operations. Let's see, what's x divided by y? So 1 divided by 3, right? Again, in Java, compute the quotient, so that's 1/3, so 0.3333. Throw away the 0.3333, you get 0. Right? Z divided by y, so 13 divided by 3 is 4 and a bit. Right? So throw away the and a bit, and you get 4. OK, now what happens if you take two int values and two positive int values, add them together, and it's bigger than int max value? Right? So what happens in Java is the value wraps around to the other side. Right? So if I start out with integer max value, right, that's the largest max value. That's the largest value I can store in an int. Right? If I add 1 to it, so what happens is, let me draw a number line here. So if you imagine that's your number line, right? Integer min value is down here. and max value is over here, right? So that's integer max value, integer dot max value. Right? So if I start here and add 1 to it, it wraps around and comes back to here. Right? So you end up with integer min value. And so what does that mean? I can add 2 positive values and end up with a negative value, right? Which mathematically doesn't make sense, right? Unless you've taken a discrete math course and you've done modulo arithmetic, right? So you have to be careful of this phenomenon that occurs when you're doing integer arithmetic, right? The values can overflow in this case. We call this overflow. I think I tell you what this is. Yeah, I tell you this in a second. Right? Now what happens if I start out at the largest value, right, and then add 2, right? So you wrap around and you end up at the smallest value and then you add 1. So you end up at integer min value plus 1. Right? If I start here and add 3, wrap around and then add 2, right? And you end up at integer min value plus 2. Right? So addition always goes right. Well, addition of a positive value always goes right, and then you wrap around again if you fall off the end. Subtraction works the same way, except you fall off this end. Right? So if I start at integer min value, whoa, sorry. If I start at, where'd you go? Oh, wait, why did I start at, oh no, sorry, here. If I start at integer min value and subtract 1, right, you fall off the end and come back to the other side. So you end up at integer max value. Right? So the same thing happens with multiplication. Right? If I take 2 positive values and multiply them and they're bigger than this, you wrap around and you just keep on adding the remainder that wraps around to this value here. Right? Now you might think this is weird, but this is an actual phenomenon. This is the way a lot of the older languages, well, not all, but a lot of the older languages defined integer arithmetic this way. One of the reasons it's defined this way is because it's easy to implement in hardware. Right? So this phenomenon is called overflow. Right? So when I fall off this end to the left, or if I fall off this end to the right, that's called integer overflow. Right? So that occurs when an arithmetic calculation with an integer type results in a value that is outside the range that can be represented by the type. Right? Java says that wrapping shall occur if integer overflow occurs. But other programming languages will define what happens differently. Right? Some of the quote-unquote safe languages, so the languages that are defined for mission-critical systems, will often throw an error of some kind. Right? So if you overflow, something, an error condition occurs. Doesn't happen in Java. This is all silent, nothing. You get no warning, nothing. Right? There's no compiler warning. There's no runtime warning. All that happens is that overflow suddenly occurs. You might think this is weird. It is. A lot of people don't look for it because it usually doesn't happen. Right? But this list here, right? This is a list. This is an incomplete. This is a very short but incomplete list of significant incidents that occurred, in part caused by integer overflow. So we just take a quick look at some of these because these are Ariane 5. These are interesting and sad actually at the same time. Ariane 5, that's the previous generation European Space Agency rocket. The inaugural flight ended up crashing shortly after liftoff because of integer overflow. Right? We're talking hundreds of millions of dollars lost. Fortunately, no one was on board. Right? Satellite was lost, satellite or satellites were lost, and the rocket itself was lost. Therac 25 is a very sad story. So this was a radiation therapy device, a medical device made by Atomic Energy Canada. It had a lot of software issues and a lot of hardware issues. But it was released. Doctors were using it. It ended up severely injuring and killing, I think, 2 people. So there were 6 people who were overdosed, massively overdosed with radiation. Right? I think 2 of them died. So this is very sad. And then the device was pulled off the market. Right? It had many errors. One of them was an integer overflow bug. Right? Year 2000, this used to be more relevant, but most of you were born after the year 2000, so you wouldn't have even heard about this. So back in the late 1990s, there was a lot of concern about what was going to happen at midnight of, or 1 minute before midnight anyway, of the year 1999. Right. So just as the calendar year was about to roll over to the year 2000, there was a huge problem in a lot of computing systems. Right. So a lot of the older computing systems stored years as 2 digits. right? So the year 1997 would be stored as 97, right? And so banks and other financial institutions and lots of other institutions would do arithmetic with these years, right? So how old's a person? Well, 1997 minus 1991 is 6, right? So the person's 6 years old or something like that. Could be off by 1, right? Now the problem is what happens when suddenly the year hits 0, 0, right? If you were born in 1991, your age is now minus 9, right? Which is a problem. It's a huge problem, right? Especially if you're dealing with banking. Insurance, all sorts of things, right? Anything that dealt with a date, this is a huge problem, right? Why did this occur? It's because we used to store dates as, or years as only 2 digits. Why did we only store years as 2 digits? Because it used to be the case that memory and storage space is very expensive, right? Today it's outrageously cheap, right? You buy a USB key for like $3 and you got like 16 gig of data, right? Back in the day, right, that would cost you millions of dollars, right? If they could even give you that much RAM. Right? So this was a huge problem. We spent billions and billions and billions of dollars fixing this problem. Same problem is going to happen in 2038. Right? So all Unix systems store time as an integer value, as the number of seconds past midnight from, I think, January 1. Does it tell you here? Yes, January 1, 1970. Right? So it's stored as an int value. Right? As when you hit the year 2038, that value overflows, right? And now Unix time breaks, right? All your GPS systems, they all have to account for the fact that they store the week as a, I think, 2-digit number or something like that. And that number eventually overflows, right? So every couple of weeks, your GPS system has to account for this fact that there's this overflow problem in the GPS standard. Right? And the list goes on and on and on. Like if you search for this, you can find lots and lots of examples where this problem occurs. Now, in Python, this doesn't happen, right? Because in Python, ints are objects, right? And so we're not stuck with this limitation of only having 32 bits. If I write a big int, right, the way the Python language works is it allocates enough memory to store the number, right, and magic happens, right? So Python programmers almost never see this problem. All right, so that's enough about int for now. Double is your choice for routine calculations involving floating point values, right? So a value that's supposed to represent a real number. Right? Now, again, there's a finite amount of memory used to store a double. So that means there is a minimum and a maximum value, and there's only a finite number of double values. Right? There's a lot of them, right? 2 to the power 64, so there's a lot. But there's only a finite number. Right? So you cannot represent every real number as a floating point number on a computer. Right? So double max value is very big. It's on the order of 10 to the power 308. Right? So an outrageously large number that has very little practical purpose. Right? The smallest value is just the negative of the largest value. Okay? Now doubles are a bit funny, because there's also a smallest positive value, right? So the next value that's larger than 0, right, is stored in double min value, right? So double min value is not the analog of integer min value, right? The analog of this in double is negative double max value, right? Double min value is the smallest positive value, right? So the smallest value greater than 0. That turns out to have a lot of significance if you do numerical analysis, right? So if you're a person that studies calculating stuff on a computer using numbers, this value becomes quite significant. Okay, so if you write a sequence of digits, and that sequence of digits has a decimal point in it, right? 1 decimal point in it somewhere, then Java says that is a double value. Okay, so if I write 1.0, that's the double value 1.0. If I write 2 dot, that's the double value 2, right? Like ints, you can put in underscores if you like. You also have scientific notation, right? So some number, it doesn't have to be a double, it can be an int, right? Followed by an e, followed by an integer value. The way you read this is as this value here. So 1.000000099. The e is times 10 to the power 6, right? That has to be an integer power, right? So that's roughly 1 times 10 to the power 6, so roughly 1 million. So just like ints, if you do arithmetic with two double values, you get back a double value always, right? Even if the value exceeds the minimum value or the maximum value of the range. Right? So here I've got 1, 3, and 13. Right? Add them together, you get 4.0. Right? Subtract them, you get -2. Right? So on and so on and so forth. So this works the same. This works exactly the same as it works in Python. Right? So the double values and the Python float type behave exactly the same because the Python standard says that float basically follows what's called the IEEE 754 rules, which we're going to talk about probably not today, but a little later. Right? So Java and Python, their floating point types behave exactly the same for the most part. Okay. Now, unlike the integer types, the floating point types don't wrap. Right? So if I take two really, really big double values and multiply them together, right, it doesn't wrap around the other end. Right? So it's different than the way that int behaves. Right? So for the floating point types, the values saturate. Right? So that is, if you try to calculate a value that's bigger than the largest double value, then you end up with this value called double.positive infinity. Right? So take two huge double positive values, multiply them together, you end up with infinity, right? Positive infinity. If you take a negative and a large negative and a large positive value, multiply them together, you get double.negative infinity. Right? So instead of wrapping around, it stops at the end, right? Or saturates. Okay, so that's you've used the float type in Python, so you basically know how to use the double type in Java, right? Everything's basically the same. All right, so what about functions or methods in Java? So you know Python. A lot of what we try to teach you in your Python courses was what's called procedural programming, right? Break down your program into procedures, right? Or functions. Call the functions because they're reusable. You write them once, you debug them once, and yada yada yada, right? All that good stuff, right? So here's a function called max2 in Java in Python, right? It's a very weird version of max, right? So this takes the maximum of two integer values, a and b, right? So I've got some integer value a, some integer value b. I want to find the maximum value, right? Don't do it this way, right? This is only for illustration purposes. Right? Normally, you just write an if statement, right? But it turns out you can do some math and get the same answer, right? So to find the max of two values, I claim you can add them together and then add the absolute value of the difference. Or wait, sorry, add them together and then add the absolute value of the difference. Yes, and that gives you the maximum value. Is that right? I wonder if I forgot to fix this slide. Sorry, a plus b. Oh yeah, right. You add them together, right? Add the absolute value of the difference, and then divide by 2. And that gives you the maximum value. Right? If you sit down and play around with this equation here, right, you can relatively quickly convince yourself that this is in fact the case. Right? It's weird. Don't do it this way. Right? There is a reason it's written this way, but if you're to write max2 on your own, just use an if statement. Right? Now to call max2, right? You know that in Python, you just write max2 round brackets, pass in the arguments to the function, right? And if the function returns a value, you can store it in a variable, right? Well, Java is exactly the same, except, right, Java has no functions. Right? So the closest thing that Java has to a function is what's called a public static method. Right? Now, don't worry what public static means right now, right? Just accept the fact that there's this stuff that you have to write in front of it, right? And I'll explain exactly what public means and what static means in a later lecture. Right? Similarly, right, in a Java module, the function can live on its own, right? You can write as many functions as you want in a Java module, everything's fine. That's not true in Java. Sorry, did I say Java or Python? In a Python module, you can write as many functions as you want. The functions live on their own. In Java, all the methods have to live inside a class or classes, right? So you can put methods in multiple classes, right? So I'm going to make a class called lecture2, right? Inside that class, there's a method called max2. There's a method called max2, right? I have to write public static in front of it for the time being, right? So for the time being, we're going to write public static in front of all of our methods, right? It can have a parameter list, just like a Python function can have a parameter list, right? The main difference is you have to specify the types of the parameters in a Java method parameter list, right? So the method max2 takes in an int a and an int b, right? Python being dynamically typed doesn't care about the types a and b here, right? Java being statically typed does care about the types a and b, right? So you have to specify the types a and b here. And then everything else is more or less the same, right? Except calling ABS, the function, the method ABS. In Java, all methods belong to a class, right? It turns out the absolute value method belongs in the class called math in Java, right? So big M math is the standard class. I guess it's the standard library class that defines math operations in Java, right? So things like absolute value, I think there's a min and a max there, and a bunch of other things. Right? Return statement's the same as in Python and Java, right? So if I want to return a value, you write return and then the value. Public static, there's a mistake. Sorry, I just saw it. Public static int. Okay, do I tell you about it here? Oh, hey, no, just a second. I just want to quickly scroll through. Yeah, there's another mistake there. All right, I'll have to fix that too. Oh, Java methods. So Python function, right? You don't say what the function returns, which is really annoying, actually, if you come from a Java language like Java or C, right? So this function does not say what it returns. To figure out what a function returns in Python, you have to go read the documentation, right? Now, the other thing in Python is that you can return as many things as you want from a Python function, right? Because you can return a tuple of values. Both of those things are false in Java. So in Java, you're allowed to return one value, and only one value at most from a method, right? You have to say what the type of the value that's returned is, right? So public static int max2 says that max2 returns an int value, right? If a method returns a value in Java, it must return a value, right? So this return statement has to be here, right? Python, you can delete that return statement. Python's perfectly happy with it, right? You won't get the return value from the function, but Python doesn't care. Okay, to call max2, a method in another class. Now remember, methods in Java live in classes, right? So I can make a separate class. So here's test lecture 2, right? Back here, the max2 method is in the class lecture 2. Here I've got a second class called test lecture 2, right? So if I want to use that max2 method inside this class, I need this import statement here, right? So import lecture 2 says import the class lecture 2 into this file so that I can use the facilities that are defined in the lecture 2 class. Right? So I import the other class that I want to use, right? And then when I call the method, I use the name of the class in front of the method, right? So now I've got lecture 2 dot max2 5 comma 3, 5 comma minus 3, right? So I have to import the class that I want to use, right? And then call the method using the name of the class, right? The way you call the method is going to change slightly as we move through the course, right? So when we start talking about using objects, this is going to change a little bit, right? But for now, right, whenever I call a static, well, sorry. For now, whenever we call a method, we're going to use the class name in front of the method name, right? Whenever you call a static method, right? So that's a static method in Java. Right? So whenever you call a static method in Java, you always use the class name in front of the method name, right? And it's the class that defines the method, right? So it's lecture 2 dot here. It's not test lecture 2 dot here, right? Max2 is defined in lecture 2. So to call the method, I have to use the name lecture 2 dot. Right? All right. What's the other big difference between Python and Java? Indentation is a big thing in Python, right? So Python made the curious decision to have indentation indicate to be significant in code, right? So when I define a function in Python, I have to indent the body of the function, right? Whether you use spaces or tabs doesn't matter, but you have to be consistent, right, in Python, which is also aggravating. So here I've got 4 spaces in front of the body of the function. Right? If you leave the spaces out or if you change the spacing between lines, the Python interpreter complains. right? It says something about the indentation level not being consistent or something like that, right? You have to go back and fix your indentation. When I fix the bug here, sorry, public static int. All right, so Java does not care about white space very much. So it certainly doesn't care about indentation at all, right? So indentation in Java is only used for readability. Right? The compiler does not care what your code looks like, right? Now, who cares what your code looks like? It's people that are reading your code that care what your code looks like, right? And so indentation is used to make your code readable to other programmers, including yourself, right? So in order to figure out how should you indent and space your code, right, you should just follow along with the lecture slides and the notebooks, because the notebooks and the lecture slides use the exact same style conventions. Right? Everything is indented consistently, everything is named consistently, blah, 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 right? So on and so on and so forth, right? So here, I can write my lecture 2 class like this if I wanted to. In fact, you can get rid of all the new lines and all of the indentation if you wanted to, and the compiler is perfectly happy with it, right? Trying to read this is awful, and it's only 3 lines of code, right? So don't do this, right? Instead, do this, right? So class is not indented, right? If it's an upper level, if it's a top level class, right? All methods start with 1 level of indentation, right? Every method body starts with 1 level of indentation relative to the method header. This is called the method header right here. Right? For your braces should go either at the end of the line, right? The following is also acceptable if you want. You can put them at the beginning of the line if you like. But whatever you do, be consistent. So if you're going to do this, right? If you're going to indent your if you're going to delimit your blocks of code with aligned opening and closing brace, then you should do that everywhere. So if you're going to do that, do this as well. Right? Both of those are acceptable in this course. I always use the brace at the end. Right? But this is acceptable as well. Oh, talking about braces, Java uses braces to delimit the bodies of classes, methods, if statements, loops, and other things as well. Braces are required, right? So those red braces, right, those braces delimit what's called the block of code that defines the body of the class. Right? The blue braces, right, those define the block of code that delimit the body of the method. They are required for the class, and they're always required for methods. Right? So whenever you write a method, you write down the method, and then right away it's brace, brace. Right? Oh, okay. We're not done yet. We're moving to the next lecture. Okay. Get rid of this from number 3. And I think we're actually a ways into lecture 3 already. So here we go. All right. So now I'm going to tell you about, well, I'm going to start to tell you about public and static and all these other funny words that are flying around. Right? So all of our classes so far have been public, class, class name. Right? The way you write these keywords, public and class, is important. Right? It's all lowercase. If you try to use uppercase or spell it differently, the compiler will complain. Right? So for the time being, any class that we write is going to be public. Right? Now this, so Java has the notion of what's called an access modifier that Python does not have. Right? So an access modifier determines what classes can see other classes. Right? So if lecture 2 says that it's public, then lecture 2 is saying, hey, any class can see the class lecture 2. Right? So the public access modifier on a top-level class means that the class is visible to all other classes. Right? Any other class can use lecture 2. So that's what public means. There's a public. There's another. I have to be careful here because there's 4 access modifiers, but not all apply to classes. There are other access modifiers here that you can use on a class. Right? For now, everything's public. Right? Also, for the time being, all of our methods will be public, right? So there's our method public, right? And static. So if you put the public access modifier on a method, right? So here max2 is public, inside the public class lecture2, right? Then that means that any other class can call the max2 method. All it has to do is import the class lecture2. Right? So public just means everybody can see this method. Right? All right, now, also for the time being, all of our methods are called static, are labeled static. Right? So the static modifier means that the method belongs to the class. Right? And so what public static int max2 means, this max2 method belongs to the class lecture2. Right? You use the class name to call the method. Right? So if somebody imports lecture2 and wants to use max2, they always write lecture2.max2. Right? All right, so if it's static, always use the class name of the class that it's defined in to call the method. For now, all of our methods are static. That's going to change in a few weeks. Okay, static, method belongs to the class. Parameters of a Java method have types, right? So I already told you this, right? So the method max2 has two parameters, A and B. They have to have types, right? You must specify the type for every parameter, right? A and B here are just variables that belong to the method now, right? So inside the method, you can use the name A, right? And inside the method, you can use the name B, right? Those correspond to the values that were passed into the method. A Java method is, did I fix the, oh, see, I fixed these ones. I didn't fix the earlier ones. Okay. So a Java method is allowed to return 0 or exactly one value. You cannot return more than one, which is a little bit annoying. Right? If a method returns a value, it must declare the type of value that it returns. Right? So I want max2 to return the max of A and B. Right? What's the type of A and B? Well, it's int. So it makes sense that the method max2 also returns an int value. Right? So the type should appear immediately before the method name. I don't remember if it has to appear immediately before the method name. It's possible that you can move the order of public and static and int, but I don't remember exactly. Right? So I'm always going to write it as public static int. Right? It may be possible to write this as public int static. I don't remember. Almost all Java programmers write it public static int. Okay, if a method does not return a value, right, then it must return, must say that the method returns the type void. Right there. Right? So the main method in a Java programmer, the main method in a Java program does not return a value. Right? And so to indicate that the method does not return a value, you use the keyword void. So main is one of these methods that always returns void. Do I have another example here? No. Right? If you want to write a method that returns no value, the return type is always void, right? And it has to be there. Max2 says that it returns an int value, right? So the fact that it returns an int value means that the method body must contain a return statement in it, right? So I'm going to return twice max divided by 2. The value that you return, right there, right? So that value there has to be an int, or it has to be something that is automatically convertible to an int. Right? Don't worry what that means right now. Right? For now, just remember that if a method says it returns an int, then that value there has to be an int. Right? The method stops running when it sees a return statement. Right? So as soon as the method hits the return twice max divided by 2 line, right, it computes that value, returns it back to the caller, method stops right after that semicolon. Right? So the method stops running immediately after the return statement finishes running. Do I tell you what it says? I'm just going to quickly scroll through. Give me a second here. Okay, I don't think I actually tell you. Right? If you try to, Okay, if you try to write extra code after this return statement, the compiler will flag that as an error. Right? So for example, if I try to print out twice max divided by 2 after the return statement, the compiler says that that's an error. It calls it unreachable code. Right? It's unreachable because the method stops at the return statement. Right? So you're not allowed to put any significant code after a return statement. A void method has no return statement, right? So if a method returns no value, then there's no return statement, right? So main has no return statement. If you want to, you can put in an empty return statement, right? But don't do this. No one does this. Well, I shouldn't say no one, but it's uncommon, right? All right, what about if statements? So in Python, you've got your if, elf statement, right? You've got some conditions up here, right? You got conditions here, right? You know you can have an else clause in a Python if statement. I'll forget about it for now, right? So here's max 3, right? I want to compute the maximum value of 3 values, right? So here I'm going to compare A and B and A and C, right? If A is bigger, I'm going to return A, right? I'm going to set the result to A, so I'm not going to return A, right? Else, right? So if A is not the biggest value, I'm going to compare B to A and C, right? And set the result to B if B is in fact the largest value, right? Now, if neither of these two cases are true, then it must be the case that the largest value is C, right? And then at the end of the function, I'm going to return C, right? Or sorry, I'm going to return the result. Okay, so the corresponding method in Java looks similar but slightly different, right? Okay, so here you've got if and then the condition, right? In Java, you have if, right? And then the condition must be inside parentheses, right? So these round brackets, they have to be there, right? Otherwise, you'll get a compiler error, right? So if round bracket and then the condition, right? Now, a lot of the operators are the same, right? So greater than, equal to, less than are similar in the two languages. What's not the same is and or, right? In Python spells out and, right? So, what the heck is, sorry. Okay, right? In Java, the and operator is the double ampersand, right? So and. Don't use the single and, right? So a lot of programmers that are new to Java will just use single and everything seems to work until it doesn't, right? The single and is actually something else in Java, which I'm not going to, don't worry about it for now, right? Use the double ampersand if you want to compute logical and. Right? Now, elif in Python translates to else space if in Java. Okay? Again, round brackets are needed around the condition, double ampersand for logical and. Right? Notice that the body of each clause, right, is delimited with braces. Right? And I'm always going to delimit them with braces. If you've programmed in Java before and you say, hey, there's only one statement here, I don't have to put it in braces, you're right, but I'm always going to put it in braces. Right? And then the return statement is similar. Right? In both cases, you can remove the else clause. Right? You start out by assuming the largest value is C, right? And then you have an if statement to fix the result if the largest value is not C. So the corresponding method in Java, right? I want the result to be C, so I'm going to create a variable called result. Right? I'm computing the max of 3 double values, so my result type is also double. And I'm going to initialize it with the value C. Right? And then everything else is the same. Conditions must appear inside parentheses, sorry. Right, which is not the case in Python, right? Although I think you're allowed to put them in parentheses in Python. In Java, they have to be inside of a parentheses. The parameters here, I told you earlier, those are just variables that are local to the method, right? So your parameters A, B, and C, right? These methods have meaning inside the body of the method max3, right? And so we call that the scope of the parameters, right? And you should have been told this in Python too, right? The scope of a Python parameter is, of a Python parameter in a function is the body of the function, right? Same thing is true in Java, right? The scope of these parameters here is the body, right? Delimited by the braces of the method, Right? Now in Java, the scope starts where the variable was declared. It goes to the end of the block in which the variable was declared in. Right? So for methods, these variables are, we pretend that these are declared inside the braces. Right? And then anywhere inside the braces, you can use the names A, B, and C. Right? Now, what about this variable C? Result, sorry, what about this variable result? So here, on the first line, right, I made a variable called result. Right? Its type is double. Right? So the scope of the variable result is from this point to the end of the block in which the variable was defined in. Right? So result was defined in this block here. So it's visible as soon as it's declared to the end of the block. Right? Which is why I can use it on the first line. Sorry, I declare it on the first line, and I can use it on the last line of the body. Okay, now, you have to be careful in Java. Right? So the scope of the variable is the region of code where it's usable. Scope starts where the variable is declared and goes to the end of the block in which it was declared in. Right? So if you try to write the following, right? Here's my if statement, right? So if this if statement is true, the largest value is A, right? So you might write double result equals A, right? Which is a problem because the name result is usable only inside of that block, right? So I declared it here inside this block, so it's only usable inside that block, right? Which means it goes away as soon as this block of code is done, right? Similarly, you might write double result equals B here, right? Again, I've declared the variable result inside this block, so it's only usable inside this block. Notice that I can declare the same variable name as long as they are inside completely separate blocks, right? So this block here, right, ends the scope of result, which means in this block here, I can reuse the name result, right? If you try to return result here, your compiler now says that there's a problem. There's no variable called result, right? Despite the fact that you said there was one here and one here, right? So the error here is that the scope of these two values, of these two variables, is only the block in which they're defined in, right? So you have to be a little bit careful about scoping and where you declare your variables in Java. You are allowed to have more than one return statement in a method, right? But there can't be any code immediately after the return statement in the same block, right? So there's no reachable code allowed after the return statement, right? So if I wanted to, instead of making a variable called result, I can just return A here, and that's fine, right? It's fine because if you reach this line of code, right, the method stops. Right? So there is no code after this method, right? And the only way to reach this line is if this if statement is true, right? If the condition in this if statement is true, right? Similarly here, I can just return B, and this is fine as well, right? Even though there's code after it, right? There's code after it, but there's no code that can be reached if this return statement runs, right? And so return C here is fine, but I can't put any code after it. Right? So if you want to, you can write your method like that as well. Right? People who study software engineering will complain that you wrote it this way. They'll complain because you have multiple return statements and it's hard to check the correctness of this method. I think most programmers, a lot of programmers would in fact write this method this way. Right? They take the more pragmatic approach. Right? Let's see. Oh, this one's funny. Okay. So if a method returns a value, it must always return a value. Now you have to remember that your compiler is not a human, right? It's not going to try to logically go through your code and deduce that in fact a value is always returned, right? So here we've got return A, return B, return C, right? And they're all part of the if statement, right? So in this example here, if you try to compile this piece of code in a Java compiler, the compiler will say, hey, you don't actually return a value inside this method. Right? It's going to say that missing return value. Right? Why does it say there's a missing return value? Because the compiler doesn't look at this and say, oh, this is if, else, if, else, if. And that these conditions here, right, are mutually exclusive and complete. Right? It's not a mathematician, right? Your compiler is not a mathematician. It does not realize that if this condition is true, is not true, and this condition is not true, then it must be the case that this is true. Right? So your compiler doesn't try to do any logical deduction. Right? It's dumb. It just says, oh, there's an if statement here. Right? It's possible that none of these if statements, none of the conditions are true. So there has to be a return statement here. Right? So don't write code like this. Right? If you, in fact, have conditions that are complete, right, that last condition should not be there. All right, double and or double ampersand is logical and. Right? You can't write little a and d in Java and have it work. Right? Double vertical bar is logical or. Right? And has higher precedence than or in Java, just like it does in Python. Right? So if you want to compute is a year, a leap year, right, you can string together a logical condition to do so. Right? Now, for those of you who don't know the actual definition of a leap year, right, a year is a leap year if it's divisible by 400. Right? So if you take the year, it's evenly divisible by 400, it's a leap year. Right? If it's not divisible by 400, then it is a leap year if it's divisible by 4, but not divisible by 100. Right? Okay, so what is this funny percent operator here? So the percent operator is the remainder operator in Java. Right? So take the year, divide it by 400, compute the remainder. Right? If the remainder is 0, then it's a leap year. Right? So here, so if that's not true, right, so that's false. Right? So now we have or. Right? Take the year, divide it by 4, is the result, and compute the remainder. Right? Is the result 0? Right? If that's true, right, then the year is divisible by 4. Right? Take the year, divide it by 100, compute the remainder. If that's not 0, right, then it's not evenly divisible by 100. Right? So then in that case, that the year is also a leap year. Right? Here, Here I've used the fact that and has higher precedence than or. Right? So if this and this is true, or if this is true, then it's a leap year. Otherwise, it's not. Right? Now, this is confusing to read for most people. So you can use brackets or parentheses to be explicit about the precedence. Right? I would encourage you to do this where you need to do it. Right? Because stringing together reading logical statements is a little difficult. Right? Especially when you have a lot of conditions in your strung together. All right, I think I will stop there. And let me do one more thing, and then we'll stop there. Okay, so a lot of new programmers will write this way. Right? They will say they'll write some logical condition. Right? If the logical condition is true, they will return true. If the logical condition is false, they'll return false. Right? But you have to remember here, the result of a logical expression is either true or false. Right? So if that thing evaluates to true, you should just, you don't have to compute, you don't have to write an if statement to compute, to return the right result. Right? All I have to do is compute this. Right? That there, and return the result. Right? So you should start training yourself to avoid writing the if statement. Right? If you compute a logical expression and you want to return the result of the logical expression, just return the logical expression. Right? So here you can just return the, is the year divisible by 400 or is it divisible by 4 and not 100? Right? And avoid the if statement altogether. Right? You won't lose marks for writing the if statement in this course. Right? But when you go out to work and you start writing code that looks like this, right, your supervisor is going to start slapping you upside the head, right, and saying, hey, just write this. Right? Okay? So start to train yourself to write that. But don't worry about it if you have to write this, okay, for the time being. All right, see you on Monday, I think. Someone has a problem with their computer. Who was it? Are you here?
Me.
Okay. Hey.
Thank you for remembering about that.
No problem. So you installed it, and you said that it's not working?
Yeah, so like I was trying to install it yesterday
Yeah.
in the evening. Sorry about that.
No, it's fine.
But maybe it's just a problem with my Mac. I don't know. I had some problems with it earlier as well. I think it was here. Yeah. So this is the website that I found to download like the
Sure.
one that you recommended.
Now, which one did you?
So which one was it? I
should have
did
picked Mac.
DMG installer, right?
Okay, so this is not a brand new one, right?
It's
This is
one of the newer ones.
Intel or ARM? Do you know? Is it an M1?
I think no, it's not the M1.
Okay, so that is the right one then.
Yeah.
Okay, because there's a difference. If you have the M1, you have to install a different one.
Yeah, exactly.
Okay, so you already installed it, right?
Yeah, so I installed it, but the thing is, like, it's supposed to like do something, but
Yeah.
it's not just doing anything after that.
Oh, I
So,
see.
like,
Okay,
I'll show you
I
what
understand.
I mean.
Yeah. Normally, you have to click on the DMG file. You have to double click on it to get it to do anything.
Okay.